Alright, hi everyone, welcome to my YouTube channel, City of Election. And this video might be the last one for this playlist for now, okay? For now. Now, this example is just like it's similar to the previous one. But the difference is that this is in 3-phase. Where are you? Yeah, 3-phase overhead line, 3-phase. And because it's 3-phase, what we have to do is to convert the parameters, the given data, to single phase, and then we'll do our calculation exactly the same as the previous video. We'll do the same calculation for different values, of course. So we'll do the same calculation, and then when we get our final answer, we take the answer back to 3-phase. So the only thing new here will be, how do I bring it to 3-phase? The only thing new here will be, how do I bring it from 3-phase to single phase? And then when I'm done, how do I take it from single phase back to 3-phase? That's the only thing that's new here. And maybe the idea of ohms per kilometer and things like that. Okay, so now here's the question. A 1500 kVA is received, that's receiving end, received at 33 kV at 0.85 power factor lagging. Take note, lagging, over an 8 kilometer 3-phase overhead line. Each line has R equals 0.29 ohms per kilometer, and X equals 0.66 ohms per kilometer. Calculate A, the voltage at descending end, the power factor at descending end, the regulation, that's line regulation or voltage regulation, line or voltage regulation, okay? Then D, the efficiency of the transmission line. Now note this 3-phase connect, the 3-phase is 3-phase connection is star connected, okay? Now for star connected, we've said it, okay, that's in a different video. For star connected, for star connected, what we have is this thing should behave. So for star connected, what we have is this, the voltage, 3-phase voltage, okay, 3-phase voltage, voltage at the receiving end per phase is equal to the voltage at the receiving end divided by √3. That means if I want to calculate for a single line or a single phase, I will divide the 3-phase by √3. 3-phase voltage divided by √3, that will give me the voltage for a single phase or per phase. Okay, this is for star connected. Of course, the current remains, the current is the current. Okay, now this PQ is what we have here, okay, which is this power right here, power. Now this is the value we have there, and then cos phi r, power factor at receiving end, is what? This. And then you take the cos inverse, you have this for your phi r. And the line length we've been told is what? 8 kilometer. That's the length of the line, it's a short line. Then 3-phase overhead line. Now the load at the receiving end is what? 33 kilovolt, 33 kilovolts stated here. Okay, and then the resistance per phase is this per kilometer, right? Now take note of this. Take note of this. We are given 0.9 ohms per kilometer, and the length of the line is what? 8 kilometer. So this kilometer will now cancel this to give us in ohms. Same goes for the reactance. The idea is that this is the value of resistance per kilometer of the line. So 1 kilometer of the line, we have this resistance. Are you saying it? 1 kilometer, we have this resistance. So for the 8 kilometers, how many resistance are we going to have? Or what will be the value of the resistance? Just use the 8 to multiply it. That will give you the answer. And obviously, the kilometer will cancel the kilometer. Kilometer, kilometer. Okay? And then for the reactance, we do the same thing. That will give you reactance. Okay. Oh, this is not supposed to be. All right, now the next thing to do is to make our calculation for our what? Sending end voltage per phase. Sorry for this. Sending end voltage per phase. Okay, now this should be what? 5.2 ohms. If I corrected it in the rest parts. Yeah, it's correct here. Yeah, 5.2 ohms. Where that error coming from? Okay, so let's continue. Now, sending end voltage per phase is this. We derived this formula also in the previous videos. Please watch those videos, oh, please, to help you understand exactly what's going on here. Now, what we will need, this is what we have to calculate the sending end voltage per phase. Okay, so in order to do that, we need to know this, which we already have. We already have this guy right here, but this one, do we have it? Not yet. All we have to do to get this guy is what? This formula to get it. So you just put the resistance, which is this guy, you place it there. Look at it. This guy, you plug it here. Look at it, and then you get this one. Okay, so this is for this, and then to express the angle of this will be what? This guy in what? The tan inverse of this over this. We've done this thing over and over again in the previous videos, and even in the last video we did this. So it's just to express in polar form. So this will give you the magnitude. This pattern gives you the magnitude. This pattern gives you the angle. So we have this for our impedance. But for our current, note that I said something about this root 3, right? I said something about this, and that has been done here. So we just converted the line voltage or load voltage at the receiving end. Voltage at receiving end, we converted this to what? Voltage per phase by dividing by root 3. That gave us this. Okay, so to get the power, the current per phase, we take this power, okay, and what? Note that the power is the power for the 3-phase. So the power for a single phase will be what? The 3-phase power divided by 3. So that's how we got this. So this is the power we are going to make use of. So therefore, the current per phase equals power over what? Voltage. Just from the idea of this, P equals IV, right? Therefore, P over V equals I. That's what's happening here. I equals P over V. You know that this Q is also P, power. We said this earlier. Alright, so we just plug in the value. What is the value of Q or P? Put it there. The value of VR, put it there. VRO, that's per phase voltage at receiving end. So when you do this, you get these values here. So these are current. And of course, the power factor, we've done that here. The power factor, from the power factor we are able to get the phase angle at the receiving end as this. But because it's lagging, we are going to put a minus sign in where the angle of the current at receiving end. Since we have done this, now we can put in the values. Impedance, in order to get this equation. Impedance, look at the value. Current, look at the value. So we'll just substitute that into this. This value here is what we have as this. So we'll put in that value here, and this is for impedance, this is for current. And then we do exactly what we did in the previous video, which is multiply this and then you sum this, and that will give you this part. Then you convert this part to what? Rectangular form, which is what? Cos this, cos of the angle, and then sine of the angle. Of course, J is together with the sine part. And then you multiply by the magnitude. Multiply by the magnitude. Magnitude times this. Okay? Magnitude times this. Okay. Now you can sum this real part to this real part to give you this. And then you now have this. V voltage ascending end per phase, you have it as this. Now you convert this to polar form to give you this. Okay? So this is your magnitude. But recall that VSP, voltage per phase, equals the 3-phase voltage divided by √3. Since we have calculated the magnitude for voltage per phase, to bring it back to the 3-phase voltage, you multiply by what? √3. That will give you this answer. Okay, so this is what we have here. So this is our voltage. Note the angle remains the same. The phase angle remains the same. Okay, so that's that. Then to calculate the power factor at the sending end is just to say cos phi s, where phi s is the difference between phase angle of the sending end voltage minus the phase angle of the sending end current. So look at this. This is for sending end voltage. Put it here. Sending end current, where is that number? But this is it. Let me check for it so that we'll know we are together. Yeah, look at it. Sending end current, that's it. So we bring them together. Of course, minus minus that will lead to plus, and that gives us this. Because the phase angle of the sending end current is less than that of the voltage, phase angle of sending end voltage is what? Lagging. So you now take this value, you put it here. Cosine of this value will give you what? 0.8257, and that's lagging. For line regulation, this is the standard formula for line regulation. But for a short line, A equals 1. Where A equals 1 for a short line. I think I should add that. For a short line. For a short line. Okay? So once we do that, we just have it like this. And we've calculated this to be voltage ascending end to be what? To be this. Voltage at receiving end to be this. And this guy, of course, is the same thing. Multiply by 100. That will give you the value of line regulation. And D part, which is the last part, efficiency of transmission line. It is the power output over power output plus losses times 100. This is the output power plus losses is the same as input power. Power output over power input. Okay? So for power output is what? V over I. Of course, this is power now. Power equals VI per phase. So for the 3-phase, that will be what? Times 3. And then cos phi r. Okay, taking the power factor into consideration. So this is the output power. So you now say output power plus losses. The losses are the current per phase multiplied by the resistance. Current square per phase multiplied by resistance. This is per phase. So for the 3-phase, you say multiply by 3. So you just plug in your values. We already have this value. Substitute it in here. Substitute here. And then this one, we also have this value. Put it here. Same thing placed under here. And we already have this value. Place it here. Squared. Multiply by. You have this value already. Place it here. And this. Okay. Multiply by 100. that will give you your answer as 96.3758% efficiency. Okay, so of course I hope you watch this video with paper and pen so you can follow up, and then this will be all for this video, and for now this all. Okay, and go over the thing again and again, and then like, share, subscribe, comments, and I'll see you when I see you. Thanks for watching, and bye for now.